Hello everybody, in this video I would like to explain to you based on Fourier transform pairs. We know that the Fourier transform of the e to the power of j omega naught t is 2 pi delta omega minus omega naught. Now, if ft is equal to e to the power of 1000 jt, since omega naught equal to 1000, then f omega equal to 2 pi delta omega minus 1000. That's very straightforward. Okay, let's say we have a time domain signal 5 rectangularity over 50. The Fourier transform of the 5 rectangularity over 50 is 200 sin 50 over 2 omega. And if we do the Fourier transform, the second Fourier transform to the output of the first Fourier transform, we have to assume that the output of the first Fourier transform is now a signal in time domain, and based on the duality property, the output of the second Fourier transform is 2 pi multiplied with 5 rectangular minus omega over 50. This is what we learn in duality property. Since rectangular signal is symmetry, 10 pi rectangular minus omega over 50 equal to 10 pi rectangular over 50. So if we have gt equal to 250 sin 50 over 2t, then the Fourier transform of gt, which is g omega, equal to 10 pi rectangular omega over 50. Linearity property of Fourier transform state that if f1t, the Fourier transform of f1t is f1 omega, and the Fourier transform of f2t is f2 omega, if we multiply f1t with a in time domain, in the frequency domain, f1 omega also is multiplied with a. And if we multiply b with f2t in time domain, in frequency domain, f2 omega also is multiplied with b. And if we add these two, a f1t plus b f2t, the Fourier transform of the whole equation is a f1 omega plus b f2 omega. Now, let's say we have two specific equations, e to the power of jt and e to the power of 1000 jt. The Fourier transform of e to the power of 10 jt is 2 pi delta omega minus 10, and the Fourier transform of e to the power of 1000 jt is 2 pi delta omega minus 1000. And if you multiply the first exponent with 5 and the second exponent function with 6, then based on the linearity property, the Fourier transform of the whole signal, which is 5 multiplied with e to the power of jt plus 6 multiplied with e to the power of 1000 jt, equal to 10 pi delta minus 10 plus 12 pi delta minus 1000. So if you have ht equal to 5e to the power of jt plus 6e to the power of 1000 jt, h omega will be 10 pi delta omega minus 10 plus 12 pi delta omega minus 1000. We can plot h omega in frequency domain, and based on the plotting, h omega is actually composed of two impulse signals with different frequency and amplitude. The convolution property of Fourier transform states that if in time domain we applied convolution to gt and ht, in frequency domain it is basically a multiplication between g omega and h omega. And let's say we want to do convolution of two time domain signal in time domain, and if we use our previous example, 5e to the power of 10 jt plus 6e to the power of 1000 jt as the first signal, and 250 sin 50 over 2t as the second signal in the convolution. Since we already know the Fourier transform of both signal, we just multiply these two equations in frequency domain. So if the output of the convolution is empty in time domain, what is m omega? Let's find out. That's all. I hope to see you in the next video.